SwayamPrabha. Digital India. Educated India.
So far in this course, we have discussed planar linkages, which consisted entirely of lower pairs like revolute pair and prismatic pair. And the rest of the course will now devote to higher pair mechanisms, by which we mean there must be at least one higher pair in the entire mechanism. Higher pair means where the two links are connected either along a line or at a point. Two such higher pair mechanisms will be included in this course, and we start our discussion with what we call cam follower system, a higher pair mechanism known as in this cam follower mechanism, the input link is the cam and the follower is the output link. As we shall see, this cam follower mechanism is nothing but an exact function generation. By linkages we had approximate function generator, but by using this cam follower mechanism we can have exact function generator. Such complicated coordinated movement between the output and the input link is possible by using cam follower mechanisms, and which are widely used in various machines, particularly for timing purposes, as in the case of moving the valves of an automobile. Valves of As we know that in an IC engine, the valves have to be kept open, first move to open it, then keep it open, then close it and keep it closed. All these timing operations can be easily incorporated by having cam follower mechanisms. In case of linkages, we restricted our discussion only to planar linkages or two-dimensional linkages. Similarly, for cam follower mechanisms also, we will restrict our discussion only to planar or two-dimensional, that is 2D. That means all the points of this mechanism will move in parallel planes. So a single view, a projected view along the line perpendicular to the plane of movement can give you the true movement of all the points of the mechanism. So these 2D cam follower mechanisms, we start our discussion with classification. Classification can be based on various criteria, and the first we base our criteria on type of input movement. If the input link, which we call the cam, rotates, has angular motion, then we call it the cam has rotational or angular motion, then we call it a disc cam or plate cam. And if the cam movement is translational, that is linear oscillation, let us say linear to and fro motion, then we will call it a wedge cam. Before we get into the detailed discussion of this disc cam, let me first draw a figure to tell you how a cam follower mechanism looks like. This is a cam follower system. This profile body is called the cam. This has a revolute pair with the fixed link, that is the foundation, which I call link number 1. So cam is link number 2. There is a revolute pair between 1 and 2. And this is the output member, which is the follower. And as we see, if this cam rotates, depending on the profile or shape of the cam, the follower will have translatory motion in the along this prismatic pair between 1 and the follower. So this is again a 4-link mechanism. Fixed link number 1, cam is 2, this roller is 3, and this roller is having a revolute pair with this output member or the follower, which I call 4. So uniform rotary motion of this cam will have rectilinear oscillation of the follower along the guide. This is a prismatic pair. There is a revolute pair, there is a revolute pair, and between 2 and 3 we have a line contact, which is a higher pair. Similarly, we can have a wedge cam, which may look like here again we have a 4-link mechanism. This is a fixed link 1. This is the cam, which looks like a wedge, which I have given number 2. This is the wedge cam, and this is what we call disc cam. Depending on the profile of this wedge, as this cam oscillates in the horizontal direction, the follower will oscillate along the vertical direction along this prismatic pair or this guide. So here again roller is 3 and the follower is 4. So our job is to generate a complicated output motion, that is a given or desired output motion. What should be the cam profile? That is the objective of designing cam follower systems. So this is one classification based on the type of movement that the input member of the cam has. Normally we will see that this has constant angular velocity. Omega 2 is constant. So the rotation of this cam theta 2, which is omega 2 into t, where t is the time, we can see this theta 2 is proportional to time. And the movement of the output link will depend on the profile of this cam. As we have just now said that the planar cams can be classified in various ways depending on various criteria. The first classification we made depending on the type of input motion, that is here the input motion, that is the cam, has an angular motion or rotational motion. Then we call this cam a plate cam or a disc cam or even radial cam. Whereas if the cam has a linear motion, then we call it a wedge cam. Our next classification will be based on the type of movement that the follower has. As I said just now, the cam can be classified also on the basis of the type of movement that the output member or the follower has. Accordingly, the second classification is based on type of follower movement. If the follower has linear motion, as we have shown in the diagram, if the follower has linear motion, then we call it a translating follower, and if the follower has angular motion, then we call it an oscillating follower. Now, the translating follower, the axis of translation, that is the axis of that prismatic pair, if it passes through the cam center, then we call it radially translating. We call it radial translating follower if the follower axis passes through the cam center of the camshaft. But if it has a little offset, that means the axis of the translation of the follower does not pass through the cam center, it is little bit offset, then we call it an offset translating follower. Later on we will discuss why this offset is necessary and what is the proper direction of the offset, all that we will discuss later. Right now we are concentrating only on the different classification. Based on the type of input movement or cam movement, we had disc cam or wedge cam. Based on the type of follower movement, we call it, if the movement is linear, the follower movement, then we call it a translating follower, which can be either radial or offset, and if the follower movement is angular, then we call it an oscillating follower. As we said just now, these are the diagrams to explain radially translating follower, offset translating follower, and oscillating follower. As we see, this is the cam, that was link number 2, this is the follower, link number 4. As the cam rotates, this disc cam, the follower translates along this vertical direction. Here is a prismatic pair between this 1 and 4. And as we see, the axis of this prismatic pair passes through the cam center, so I call it radially translating follower. Similarly here, again the cam rotates, is the disc cam, the follower translates, but the axis of this prismatic pair passes not through the cam center but has an offset, little away from this vertical line. This offset we will normally denote by the variable E, by the symbol E. So this is called offset translating follower. Whereas in this case, as we see, the cam rotates as before, but this is the follower. Due to the shape of the cam, the follower undergoes an oscillatory motion and the follower is hinged at this point. So this is called oscillating follower. The third classification of cam follower system is based on the nature or shape of the follower surface, the contact surface between the follower and the cam, what kind of surface the follower has at the contact this is type of based on type of follower surface. If the follower is just a knife edge, if the follower has just a knife edge with the cam, then we call it a knife edge follower. It must be told that this knife edge is only theoretical because knife edge follower is never used because of very high wear rate. The follower, as we have seen already, follower surface can be, the follower is hinged to a roller and this roller is in contact with the cam, as we have seen so far. This is called roller follower. The follower can also be in the form of a flat face. As you see, the follower surface which is in contact with the cam is in the form of a flat surface. This is called flat face follower. The follower surface, instead of flat, it can be also a curved surface. This is the cam which rotates and the follower which is hinged here oscillates. So this is called curved. So these are the four common types of surfaces that we will be talking: knife edge, roller, flat face and curved face. Out of which, as I said, knife edge is only theoretical, not used in real life. It is the roller or the flat face or the curved face. The roller follower is used when a large force has to be transmitted, like in stationary IC engines. To move the valves, a large force has to be transmitted and we use a roller follower. But if the space is constricted, if there is not enough space to use a large roller because the spin has to be sufficiently big to transmit the force between the cam and the follower, and the roller has to be bigger than the pin, at least twice as big as the pin, then the roller needs a lot of space. If the space is restricted, then we can use flat face follower if the force involved is not too large, as we use in the case of automobiles. Let us just recapitulate the four different types of follower surfaces that we have discussed. This is the diagram of a knife edge follower, which, as I said, is really only for theoretical purpose. This is never used in practice because the knife edge will wear out very fast. This is where the follower is connected to a roller through a revolute pair, and this roller is in contact with the cam surface. The follower is not directly connected to the cam surface. The follower is hinged to a roller and this roller is in contact with the cam surface. Here we call it a roller follower. But we can use a flat face follower which is directly in contact with the cam surface. So this becomes a three-link mechanism: the fixed link 1, cam 2, which has a revolute pair with the fixed link here. This is the cam shaft in its bearing, and the follower is link number 3. Whereas here we had 2, roller is 3 and follower is 4. Instead of a flat face, we can also have a curved face as shown here, and then we call it a curved face follower. So we have just finished classification of different kinds of cams and followers based on the type of input movement, based on the type of output movement, and based on the type of surfaces that are in contact between the cam and the follower. Before we get into the further discussion of various nomenclature that will be used to describe, analyze or synthesize cam follower system, I would like to bring out one important point in the cam follower mechanism. For that, let us look at this diagram. This is the cam, which is a disc cam, and this is a translating roller follower. What we should note that as the cam rotates, the cam can drive the follower only in the upward direction. Whereas when the follower tries to come down, there is no tensile force can be applied by the cam onto this roller, so it comes down either by gravity. To ensure that the contact is always maintained during the upward motion and the downward motion of the follower, normally we use springs. The spring is connected between this guide and the follower such that when the cam is rotated, the follower goes up, the spring is compressed. So when the follower shape is such that cam shape is such that the follower wants to come down, it is this spring which will try to return it back, ensuring that the contact between the cam and the roller is never lost. In the absence of the spring, as we see, if we leave it only to gravity, the maximum acceleration can be g in the downward direction. But if we want the follower to have higher than g acceleration, then there will be loss of contact. The cam will rotate, but the follower will not follow the cam profile. To ensure the contact during the entire stroke of motion, we use this spring. Similarly, for this oscillating follower, roller follower, again we have a spring to ensure that the follower can be driven in this direction by the rotation of the cam, but that to ensure that the contact is always maintained even while the follower has to come in this direction, it is this spring which will help to maintain the contact between the roller and the cam surface. So these are the springs. There are other ways of ensuring this contact during the entire stroke of motion even without the spring, which will be explained in the next diagram. In this diagram, as we have shown, no spring is necessary because the roller follower is placed in a groove. The shape of the groove is nothing but the shape of the cam, which will dictate the type of angular motion that this follower will have. So this is the cam and this is the follower, and this roller 3 has been placed inside a groove in this body 2. So as this body 2 rotates, depending on the nature or the profile of this center line, this roller will be pushed up or brought down, and it will be always within the groove. There is no chance of losing contact either during this motion or during this motion. As we see, there is no need of spring, but this cam is more complicated than the previous one where we used a spring because you have to cut a groove. Same thing is shown here. Again, we do not need a spring, but we are using 2 rollers with this follower. This is the follower. It has 2 rollers, and as this cam rotates, either of these 2 rollers will be pushed. The cam can only push the roller, can never pull it. So either this roller will be pushed during this motion or this roller will be pushed during this motion. So both clockwise and counterclockwise motion of the follower is ensured without the use of a spring. Similarly, here what we call a constant breadth cam. The cam profile is such that it will be contact at both surfaces, so both up and down motion can be ensured by the rotating cam. No need to use a spring. This is called constant breadth cam. But we will restrict our discussion on the cams where we shall assume there is a spring to ensure contact during the entire stroke of motion. Now that we have discussed all types of cam follower systems, we have classified different types of cam follower systems, let us get into the details design of cam follower systems But for that, first we need to establish the nomenclature, that is the terms which will be used very frequently. So we start with nomenclature for we will be discussing only radial cams. So nomenclature for radial cam. We will introduce all the terminology with reference to an offset roller follower. So let us talk of a plate cam which has an offset translating roller follower. That means the follower axis is not passing through the cam center, it is offset. We assume that the cam is rotating in the counterclockwise direction. This is the roller center. This is the roller. This is the follower. This is the guide for the follower to move in the vertical direction. That is a prismatic pair. So first we define what we call a trace point. If we want to describe the motion of the follower for a translating follower or for an oscillating follower, we must say which point of the follower we are going to describe the motion of the follower by using which point of the follower. So trace point is a theoretical point on the follower, the movement of which describes the follower movement. For roller follower, it is the center of the roller. So this trace point is roller center. That means the movement of the follower will be described in terms of the motion of this roller center. Of course, in this case it is same for every point of the follower, but for an oscillating follower we will still concentrate only the circular arc along which the roller center is moving. It is the movement of this roller center that will be used to describe the motion of the follower. If it is a flat face follower, then the trace point we use is the point on the follower face which is in contact with the cam surface when the follower is at one of the extreme positions. We normally use that extreme position when the follower is closest to the cam center. When the follower is closest to the camshaft center, camshaft axis. This camshaft axis is O2. As we see in the case of a flat face follower, at this instant, it is this particular point of the follower face is in contact with the cam surface. But as the cam rotates and the follower moves up and down, this point of contact shifts on the follower face. So we concentrate when the cam is at its lowest, when the follower is at its lowest position, that is closest to the cam center, whatever point is in contact with the follower face, whatever point on the follower face is in contact with the cam surface, at that configuration, that I will use as the trace point. Or we can use this axis, wherever it intersects, this point as the trace point. So, trace point is a theoretical point on the follower, which is used to describe the movement of which is used to describe the movement of the follower. So, that is what we call trace point. Second thing, we would like to define what we call a base circle. Base circle is the smallest circle let us think of the smallest circle that can be drawn with cam center as the center and touching the cam profile. This is the smallest circle that can be drawn with cam center as the center and touching the cam profile. This circle we call base circle. Smallest circle with center at camshaft axis and tangential to the cam profile. So, this red circle will refer as the base circle. As we see, the base circle really defines the size of the cam. It is the difference of the distance of the cam surface from the cam center and this base circle radius that defines the movement of the follower. So, this is the smallest circle. When the roller is in contact with the base circle, that means from here to there the follower is at its lowest position. So, this radius of the base circle we call RB, that is called base circle radius. Base circle radius is RB. Next, we define what we call a pitch curve. To define the pitch curve, we think of a kinematic inversion. If you remember the kinematic inversion, this is the 4-link mechanism: fixed link, cam, roller, follower. In this 4-link mechanism, it is link number 1 which is fixed. But in this kinematic chain, if we make a kinematic inversion holding the cam fixed, that means we allow link 1 to move and hold the cam fixed. Instead of allowing the cam to rotate in the counterclockwise direction with respect to link 1, we hold the cam fixed. That means link 1 we now rotate in the opposite direction, that is clockwise direction. And if we do that, the locus of the center of this roller, that will generate a curve which is parallel to the cam profile. This is the locus of the trace point or roller center after kinematic inversion with cam fixed. As we see, if the cam rotates in the counterclockwise direction, if we hold the cam fixed and allow the fixed link to move in the clockwise direction, the roller center will move in the clockwise direction, but it will lie on this curve which we called pitch curve. And if we now have a parallel deformation like base circle to the cam profile, this pitch curve is a parallel curve to the cam profile. Now think of a circle, the smallest circle that can be drawn with cam center as the center and tangential to the pitch curve. This circle has center at the camshaft axis and tangential to the pitch curve. This circle is called prime circle. So what we see, that base circle to the cam profile is nothing but the pitch circle to the prime circle to the pitch curve. This is pitch curve. And this is cam profile. So we have defined trace point, then this is the cam profile, then we define base circle, then we define the pitch curve, and then we define the prime circle. What we have seen, that prime circle to pitch curve is same as base circle to the cam profile. If the base circle radius is RB and the roller radius, if we write RR, R suffix R is the radius of this roller and R suffix B is the base circle radius, then it is easy to see that prime circle radius RP is nothing but RB plus RR. We have already defined that if we draw this vertical line through the camshaft axis and this is the line of reciprocation of the follower, then this distance we called offset and denote by the symbol E. E is what we called offset. Now we must remember that this offset to the right is for counterclockwise rotation of the cam. Why? That will be explained a little later. If the cam rotates in the clockwise direction, then we must provide offset to the left. So this we can call positive E for counterclockwise rotation, which I take as the positive direction of rotation of the cam. Now we define one more important parameter for this cam follower system, which we call pressure angle. The importance of pressure angle can be clear if we look at this diagram. You see, the common normal between the roller and the cam is passing through the roller center and normal to the cam profile. So this is the common normal between the roller and the cam profile. Now, if we neglect the friction, the force that the cam exerts on the roller is along this common normal. So this is the direction of the force between the cam and the roller in the absence of friction. But I want the roller to move in the vertical direction. So, but I am pushing the roller along this direction. So this angle should not be too large. The direction of the follower movement is this, direction of the force in the absence of friction is along the common normal. So, the angle between these two directions between the contact force, normal contact force, and the direction of the follower movement, that we call pressure angle. This angle phi is called pressure angle. And obviously, for smooth movement of the follower, this phi max should be less than some maximum value phi allowable. The phi will keep on changing depending on the cam profile, and normally for a roller follower we want phi max. For translating follower, the phi max should be less than 30 dB. Similarly, for an oscillating follower, the velocity of this point and the common normal, they are not in the same direction, and the angle between them will be called pressure angle. And for oscillating follower, this is for translating follower, phi max should be less than 30 degree, whereas for oscillating follower, suppose we take the case of a roller follower but oscillating. This is hinged here. Then the direction of the velocity of the trace point is perpendicular to this line. This is the direction of the velocity of the trace point, and the common normal between the roller and the cam surface. So, this is the direction of the contact force in the absence of friction, and this angle we will call pressure angle. For such oscillating follower, the pressure angle is less important, and phi max should be less than 45 degree, whereas for translating follower, phi max is less than 30 degree. Now that we know what is pressure angle, we will be able to appreciate why this offset is given in a particular direction depending on the direction of the cam rotation. If we remember that there is a spring which tries to push it back. So, pressure angle is more critical during the upward motion of the follower. As the follower is pushed out from the cam shaft, it is compressing against the spring, and this contact force, let me call it Fn, this is the normal force, that has a tendency to rotate the follower in its bearing in this guide. It has a tendency to rotate it clockwise. For this force, the follower has a tendency to rotate clockwise, and the contact will take place here and there. The guide which is supposed to guide this thing vertically, actually due to this force, it has a tendency to rotate, and the contact will take place here and there. If I exaggerated this cocking movement, then so a normal force acts in this direction, a normal force acts in this direction, and these two normal force balances the cocking moment, the moment due to this force Fn, and the friction force which will tries to oppose this motion, vertical motion, they will be mu times this normal force. If I call it n, then this will be mu n, and this will be mu n. As we see that during upward motion, the follower has to overcome not only these two friction forces, it also has to overcome the spring force. As a result, a large Fn is necessary to overcome this friction force, and the vertical component of this Fn will overcome this two friction force and the spring force. Whereas during the downward movement, the spring force is helping the follower to come down. So, this contact force will be less. So, it is obvious that this vertical component will be Fn cos phi. If the phi is very large, then this vertical component will be reduced. As a result, during the upward movement, I want phi to be low, and during the return movement, that is the downward movement, phi can be large. So, phi max is more critical during the upward movement. Pressure angle should be low while overcoming the spring force. And this particular offset, this positive offset, ensures that the pressure angle reduces during this motion when it is compressing the spring, and it will increase obviously while the follower is coming down, but at that time spring force is there to make the follower move downward. So, I do not need a large contact force. So, pressure angle can be allowed to be larger during the downward movement, but has to be smaller during the upward movement, assuming the spring is resisting the upward movement. So, this is the need for offset. Of course, all this we will have analytical expressions later on, that how pressure angle is related to all this other dimensions. So, we have base circle radius Rb, and E the offset. These are the two basic dimensions. Rb defines the cam size, and E gives the relative position between the follower and the camshaft. These are the two basic dimensions which we have to first determine before we can go for designing the cam. At this stage, let me discuss a little bit what is the effect of this offset in the flat face follower case. Before getting into the flat face follower case, let me recapitulate whatever we have discussed so far with reference to a roller follower. As we see, this is the cam profile, this is the roller, and this is the follower axis. So, we have defined trace point, that is the center of the roller. The movement of this particular point describes the movement of the follower. This circle, whose center is the camshaft, and this is the smallest circle that can be drawn, that is, it becomes tangential to the cam profile. Any bigger circle will intersect the cam profile. So, the smallest circle that can be drawn with cam center as the center and tangential to the cam profile, that we call base circle. The radius of the base circle is called base circle radius, and we denoted it by Rb. This curve, which is parallel to the cam profile passing through the center of this roller, is called pitch curve. How do we generate the pitch curve? By a kinematic inversion, by holding the cam fixed and allowing the fixed link to rotate in the clockwise direction, because the cam is rotating in the counterclockwise direction. Then this locus of this roller center, after this kinematic inversion, it will move along this curve in the clockwise direction. And this curve we called pitch curve. And the smallest circle that can be drawn with camshaft center as the center and tangential to this pitch curve we called prime circle. So this circle we called prime circle. If the radius of the prime circle is Rp, then we can easily see that Rp is nothing but Rb plus Rr, where Rr is the roller radius. This is R. And this distance, that is the vertical line through this camshaft center and this vertical line of the follower movement, this distance is called offset. This is the positive offset for counterclockwise rotation. In these two figures, we explain again the pressure angle. We have just now seen if this is the roller follower and this is the cam profile, let this be the common normal, which passes obviously through the roller center. And this is the direction of the follower movement. But the contact force, if we neglect the friction force, then acts along this direction. And the angle between the direction of this force and the direction of the follower movement, this angle phi we call pressure angle. Similarly, for the oscillating roller follower, let this be the common normal passing through the roller center, and the follower is hinged here, so the velocity of this point A is perpendicular to O3A, that is this angle is 90 degree. So this is the direction of the movement or velocity of the point A, and NN is the direction of the contact force. So angle between these two we call the pressure angle phi. We can see that this angle, which we call mu, phi plus mu is 90 degree. This is 90 degree. This total angle is 180 degree. So phi plus mu is 90 degree. And it is this angle mu which we call transmission angle in case of linkages. So this pressure angle is complementary to the transmission angle in case of linkages. In case of linkages, we ensured that mu should not fall below a particular value. We are concerned with mu mean. Whereas in case of cam, we are talking of the pressure angle phi, and we are concerned about the maximum value of phi, which must not be beyond a given allowable value. As we said, phi max for this is normally about 45 degree for the oscillating follower, and for the translating follower, phi max is normally kept within 30 degree. Let me now summarize what we have learned today. We started our discussion with higher pair mechanism, namely cam follower mechanism. We will be discussing only 2D or planar cam follower mechanism. We defined the cam and the follower, and we have also classified cam follower systems based on three things, namely the type of cam movement, type of follower movement, and the type of follower surface. After classifying these different types of cams, we have also seen the need of a retaining spring between the follower and the fixed link, such that the contact between the cam and the follower is ensured during the entire stroke of movement, during the entire cycle of movement. Then we define different terms which will be used while designing cam follower systems, namely the base circle, prime circle, pitch curve, pressure angle, and things like that. In our next class, we shall start our discussion first with a flat face follower and show what is the need of making this offset as we have seen in case of roller followers.